Hello, everybody. I am a little bit sick right now, so that's why I'm home again. I should be back at school at some point in February, but we'll see. So you should be on page 7 of your packet. Here is page 7. I'm going to walk you through pages 7 through 10. I am going to ask you to pause frequently and to try the problem on your own first, and then you can resume once you think you've solved it. So actually, let's go ahead and do that now. Please, in your groups, go ahead and pause the video and try to solve this warm-up problem. Here's the formulas that you would need. These are the formulas that I had gone over in the last video. Number with just over again, you just take that constant times the number that's on top of the sigma. You're adding an I over and over and over again. You can use this little. And if you're using I squared, you can use n times n plus 1 over 2, n plus 1 over 6 to solve n plus 1, 2, n plus 1 over 6. Okay, so here is what should have happened. Hopefully you expanded this first because 3 minus 2i squared, there's no formula for the squared part. So I basically wrote out 3 minus 2i twice and then distributed to get 9 minus 12i plus 4i squared. Okay, keeping the summation. Shouldn't drop that. And then after that, this was an optional step here. I did not have to actually break up each part of the summation, but I just want to make sure that it was clear where these formulas were coming from. So for the next part, the sum of 9 was 9 times 100. The sum of I was n is 100, so 100 times 101, which is 100 plus 1, over 2. Now the minus 12 just stays in front. It's not doing anything other than just waiting to multiply the final answer here. Same with that positive 4 in blue. That's not really doing anything either. It's just waiting to multiply that final part. And that final part here was 100 times 101 times 201, which is n plus 1, and 2n plus 1, all divided by 6. Now, I tried to solve this without using a calculator as much as I could. I think I called mercy when I had to do 134 times 101. But here is your final answer, 1293700. When I return to class, I'll show you how to do these on your calculator if you don't already know. But hopefully you got that answer. So next. Okay, this is something that we did in the last couple of units. To evaluate the limit at infinity or negative infinity, the limit as x approaches infinity, etc. Okay, let's just make sure that we're clear of this. This is the top heavy, bottom heavy thing, if in case you weren't sure. So if the degree of n of x is bigger than the degree of d of x, then the limit goes to infinity. In other words, if it's top heavy. Okay, if it's bottom heavy, oh gosh, come on. Okay, if it's bottom heavy, then that means the degree of the numerator is less than the degree of the denominator. So and then finally, if we have the degree of the numerator is equal to the degree of the denominator, you take the ratio of the lead coefficients. So that's the ratio of the lead. Your answer, for our purposes, based on this setup, we would have equals a over b. And we're going to need this because we're going to do those summations, but put a limit in front of the summation, which will be pretty fun. If there's any questions, go ahead and raise your hand, and then wait for your inner conscience to respond. Okay, so now let's go to the next page. We have 4 examples like this, and that's it. That's all I really have to show you. Let's just make sure that I'm right on this. 4 examples or 3? 3 examples, even easier. So there's going to be a lot of you pausing and trying it on your own. One thing I would recommend that I don't think I've had my students do before is, since you're all watching this together during class, at the times when you pause, check with your neighbors as well. Check with your classmates. Use your classmates as a resource, so that way you're kind of all in this together and not just you on your own. Okay, let's see what we can do here with number 1. So first I'm going to do some side work here. I'm going to take this 1 plus 2I over n squared. So let's take 1 plus 2I over n squared. Now this one I'm not going to pause on because I want you to see how to do it. This is going to be 1 plus 2I over n, 4I over n plus 4I squared over n squared. Okay, that's the first one. Second, I notice that I have this 2 over n here. I'm not going to worry about that. That's just a pain in the butt right now, and I don't need to look at that right now. Next, let's do the formation formulas. So I am summing I equals 1 to n of just 1 times 2 over n plus, actually I'm going to do, I'll take that out. Okay, that was the 1, plus the summation from I equals 1 to n of I with a 4 in front and an over n. We write that a little bit cleaner. Oh my gosh, Mr. Lakin's writing cleaner? I never thought I'd hear the word. Okay, that's this part. And then plus, again, we have a 4 over n squared out here with the summation I equals 1 to n of I squared. So please note that our top is n. We don't have an actual number up there this time. So I'm going to apply those formulas that were right here. I'm applying these formulas to what I have set up now. So if you'd like to pause and keep trying, go for it. And then resume when you're ready. For those that don't want to, here's the work. So we have n plus, now let's see, we have 4 over n. Let's put this in green. It's 4 over n times n plus 1 over 2 plus 4 over n squared, and then times n plus 1, 2n plus 1 over 6. Okay, now let's clean some of this up here. So this is equal to n plus, I have an n and an n that cancel, and I have a 4 and a 2 that go to 2. So I have 2n plus 1 plus, I have this 6 goes to a 3 with a 2 here, and it looks like I can knock down one of these n's here to just 1n. So I have plus 2n plus 1 times 2n plus 1 over 3n. Now, the limit that I'm going to take is going to be all of this. So n plus 2n plus 1 plus 2n plus 1 times 2n plus 1 over 3n. And then all of this is going to be multiplied by that first part times that part, because I never really did anything with that, times 2 over n. All right. Sorry, that's gross. That's my night in school today. Okay. So now I get the limit as n goes to infinity, and I'm going to just distribute that 2 over n in. So 2 over n times n is going to be just 2, plus 2 over n plus 1, that's going to give me 4 n plus 1 over n, plus this one is going to give me 4 n plus 1 over 2n plus 1, all divided by 3n squared. And now your top have your bottom have your thing. The limit as n goes to infinity for any number, it's just that number, 2. Here we have, so the way I look at it is I have 4n over n. If I just multiply the 4 into the first part, which is going to give me, that's ratio is the same. That's going to be 4. And if you don't know what I mean by ratio is the same, I'm talking about this part down here. If the degree of the numerator is the same as the degree of the denominator, take the ratio of the lead coefficients. So I end up getting 4n over n plus, let's move this down more. Some students wonder, well, what happened to the 1 over n, this part? So if I do 4 over n, well, this is bottom heavy, and that's just, that value is 0. So I don't look at that one. Okay, so for similar reason, I'm going to go ahead and look at this last part, plus if I multiply each one of the lead terms together, and the lead terms are 4, n, and 2n, if I multiply 4 times n times 2n, and I put it over 3n squared, I get 8n squared over 3n squared, which is 8/3. Again, that's that ratio is the same, top and bottom, so I get 8/3 here. And now I get 6 plus 8/3, which if you get the common denominator, you get 26 over 3. It's a lengthy problem, but it's doable. And I think a couple practice problems, a couple more times practicing should help you out here. But our answer is 26 over 3, if I didn't make any mistakes. All right, I'm going to ask you to go to the next one. I'm going to ask you to pause the video, try it on your own, and then if you get stuck, please go ahead and come back to the video and resume it again. Please pause the video now, and also again, when you're pausing it, please also check with your neighbors to see if they can get the right answer as well. Thank you. Okay, let's see how you did. And again, I'm sincerely hoping that you paused and tried it on your own, and you are not just copying down the answers, because if you copy down the answers, you're not letting your brain think. So please, 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 make sure you tried this on your own so you can have some success with it on the homework. All right, here we go. So I simplified the black part first, the 2 times this 1 plus 3 over ni. Come on, come on. So I simplified that part over here. All right, once I simplified that, I got 6 plus 6 over ni. And then I wasn't done there because I had to apply the summation formulas to those. So when I applied the summation formulas, I ended up getting 6 as one summation for 6n. The 6 over n went out in front of the summation, and then the summation of I was n plus 1 over 2, and I reduced that. And I reduced it to get this part. Now that 3 over n, this part here, again, I'm not touching until the very end when I need it. So I have times 3 over n here. And then what I did is I distributed to both parts. And when I did that, I got 18n over n plus 9n plus 1 over n. And because those were the degrees of the top and bottom were the same, I ended up getting 27. And I hope you got that answer as well. And again, please, please, please check with a neighbor. Make sure you're doing okay with this. Make sure you're keeping your limits each time, because you know I take off points if you don't have the limits. And make sure your notation just looks beautiful. So again, our answer was 27 for this one. One more note about this. Your calculator will not be able to solve these. The reason your calculator won't be able to solve these entirely is because you have infinity here. And we can't put infinity in the calculator. So let's go to example 3. So one thing that I didn't really point out in the beginning, I just kind of focus on the technique first, is take a look at what you're doing. You're taking a limit of a sum of an infinite amount of terms, which in and of itself is kind of a cool idea and more of a topic for BC Calc. This is the very what's the word for it? It's the very small part of BC that we'll ever do where we're doing infinite summations. Okay, but for now, let's go ahead and pause the video, try this on your own. Remember, simplify first if you can. If you can't, don't worry about it. This little 5 over n part, just leave it alone. Don't do anything with that. And again, please pause the video. Please, 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 please check with your neighbors, work with your class, and then resume when you're ready. All right, I sincerely hope that you worked with other people on this. I sincerely hope that you're having some success with this, or aspects of the problem that you're having success on. But here's the answer. Okay, so please keep in mind that 5 over n part, we are not doing anything with that 5 over n part. Like, that's just waiting until we actually need it. So leave that alone. Next, I look at this part, and I see there is no simplifying necessary. There's no expanding or combining like terms inside, so I don't actually have to do any simplifying, which is nice to see. So I took the sum of each one, and then I applied those formulas. And the formulas were, the first one would be 4n. The second one would be 20 over n times n plus 1 over 2, plus the 25 over n squared stays on the outside, n plus 1, 2n plus 1 over 6. Please note that I took these 25 over n squared out of this 20 over n out because it is not dependent on I. Remember, I is the counter. The only thing that changes and cannot be brought out of the summation is the variable of the counter. 20 over n did not have any I in it, so I didn't have to worry about that. Okay, so finally, when I reduced, I got 4n plus this. I got this one right here. Hopefully you got that as well. And then I put my limit back in, and then that's when I put in that 5 over n part, because that's when I actually needed it. And I distribute that 5 over n to each part of my limit to get this. 4n times 5 over n is 20n over n, plus 50n plus 1 over n, plus etc. And then I show the rest of the work here that you need to be able to see to get 335 over 3. This should have been a no calculator problem. And I hope you did not use a calculator. And other than that, thanks for watching, guys. I hope to see you guys tomorrow. Thank you.